Video lecture we are going to see problems in steam properties. Myself I am Rajakumar, assistant professor, Department of Mechanical Engineering, Rohini College of Engineering and Technology. In the last video we are discussed about the basic principles of the steams and how the formation of steams and different properties and different types of steams we are discussed. But in this video the problem related to steam properties we are going to see. In the first problems, a vessel of volume 0.04 meter cube contain a mixture of saturated water and steam at a temperature of 250 degrees centigrade. The mass of the liquid present is 9 kg. Find the pressure, mass, specific volume, enthalpy, entropy and internal energy. This is the one of the Anna University question. April, May 2012 and 2015 year question paper. The given data from this problem we are taking, first of all we are read once again the problem. After that we can taking the data, given data. First of all they are given the volume, that is V, capital V is equal to 0.04 meter cube, and then temperature they are given to 250 degrees centigrade. Then mass M equal to 9 kg. Then they are asking the data about the pressure and mass and volume, that is the specific volume. They are asking specific volume, that is small v, then enthalpy, entropy and internal energy. So first of all we are see the first data. Based on our given data we are going to solve the problem. So first of all they are given the temperature, initial condition they are given temperature and volume. So from that data we are going to solve the problem. So first of all temperature 250 degrees centigrade. So we know the 250 degrees centigrade means it may be the steam is a superheat steam, we can say. So from steam table we are taking the corresponding value in the temperature 250 degrees centigrade, that is V1 value. V1 means that is a volume of fluid, that is V1 equal to Vf1 equal to 0.001251 meter cube per kilogram, and Vg, that is volume of gas or volume of steam, equal to 0.050037 meter cube per kilogram. And also pressure, they are asking the value is the pressure, that is we are taking the pressure value from the steam table, P equal to 39.776 bar. The next, total volume occupied by the liquid, that is capital V equal to, we know the formula for the capital V equal to mass into small v. So we know the values. So 9 into 0. Already we know the V1 value 0.00125 meter cube per kilogram from we are taking steam table. So we know that value is substituting into V1 equation. So we get the V1, that is total volume occupied by the liquid. V1 equal to multiply into mass into small v. So finally we got V1 equal to 0.0113 meter cube. Then total volume of the vessel, that is the formula for the total volume, V equal to volume of liquid plus volume of steam. So we know the value of the total V value and volume of steam value from the steam table. So from that value we can find out the steam, that is a volume of steam. We know we can find out the Vs value. So substitute this V and V1 value, we get Vs value, that is 0.0287 meter cube. Then mass of steam, that is formula for the mass of steam equal to Ms equal to capital Vs divided by small vs. So we know the two values, Vs capital V divided by small v. that is the total volume of steam into specific volume of steam. From that value we got the mass of steam, that is ms value. Then mass of mixture of liquid and steam, that is m equal to m1 plus ms. So we know the m1 value and mass of steam value. From the both of the value we get, so adding the two values we get the value of total mass of mixture, that is liquid and steam, m equal to 9.574 kilogram. Then total specific volume of the mixture, that is v equal to 0.04 divided by 9.574, that is the mass of mixture of liquid and steam. Then from that ratio we get the value of total specific volume, v equal to 0.00418 meter cube per kilogram. We know that v equal to vf plus x vfg. This is the wet steam formula for specific volume. So v equal to vf plus v. We know the value from vf and vfg. So from that value all the value we know except x value. So x value, that is dryness fraction, from this equation we get the value x value 0.06. From the steam table corresponding to 250 degrees centigrade, we can take the value hf value, hfg, sf and sfg. Then enthalpy, we can find out the enthalpy of steam, that is h equal to hf plus x hfg. So we know the value of hfg values. So from this value h value we know. From that value we get the h value, that is enthalpy of steam, h equal to 1188.67 kilojoule per kilogram. Okay, next we are going to see the entropy of mixture, that is s equal to sf plus x sfg. We know the value of dryness fraction s value, then sf and xfg value from the steam table. From that value substitute all the value, we get the entropy of mixture. Then finally they are asking about the delta U, that is the internal energy. Delta U equal to that is a difference between the internal, that is a enthalpy, and flow energy, that is H minus PV. We know the value of H value, P value, V value. From that value we get the internal energy. Then second problem, 10 kg of water 45 degrees centigrade is heated at a constant pressure of 10 bar until it becomes superheated vapor at 300 degrees centigrade. Find the change in volume, enthalpy and internal energy and entropy. So given data, they are given mass value m equals 10 kg, T equal to 45 degree, pressure P1 equal to P2 equal to 10 bar because the constant volume pressure. Then T2 equal to 300 degrees centigrade. They are asking change in volume, change in enthalpy, change in internal energy and change in entropy. From the steam table corresponding to 45 degree, we can take V1 equal to Vf1 0.001010 meter cube per kg and H1 value equal to Hf1, S1 equal to Sf1. So we know all the value taking from the steam table. From the steam table corresponding to 10 bar and 300 degrees centigrade, that is superheat steam. 300 degree means that is superheat steam. So we can directly taking the value from the superheat steam table. So H2, S2 and V2. So then we are going to find out the change in volume, delta V equal to m into V2 minus V1. We know the value of mass value, we know the V2 and we know the value of V1. From this value, all the values are substituted the delta V value, we get the value of 2.566699 meter cube. This is the change in volume. Next, change in enthalpy. Delta H equal to m into H2 minus H1. We know all the values, so substitute all the values. We get delta H equal to 28,637 kilojoule. Then change in entropy. Delta S equal to m into S2 minus S1. We know the value of S1, S2 and mass value. Substitute these all the value. We get delta S 64.87 kilojoule per kilogram. Thank you.